Dear students of Middle 2, welcome to the second part of our lesson, Oscillatory Motion. After we identify the concept of the oscillatory motion, today we are going to study the properties of the oscillatory motion. The properties of oscillatory motion include these four properties, which are amplitude, complete oscillation, periodic time, and frequency. What do you mean by each one of them? For the first one, which is amplitude. Amplitude is defined as the maximum displacement done by the oscillating body away from the rest point. How can we explain this concept or this definition? By observing the motion of the simple pendulum, we can explain the definition of the amplitude. Let us to see here the motion of the simple pendulum here. As you can see, the simple pendulum consists of a metallic ball which here moves as you can hit it. At first, it is at the main position, which is called the rest point. When you move it to the right and to the left, like this way, it moves around the rest point. In this case, it makes what is called the oscillatory motion. The oscillatory motion, as we see. Here, the maximum displacement done by the oscillating body away from the rest point, this displacement is called what? Is called the amplitude and is measured in meter or centimeter. But here, when it moves from B, as you can see, to A, then B, then C, then again to B, it passes by the rest point, which is B, two successive times. In this way, it moves what? It makes in this way here one complete oscillation. One complete oscillation. After that, when the simple pendulum here moves a complete oscillation, the time taken by the oscillating body here to make one complete oscillation is called the periodic time. What about frequency, the fourth one? The frequency is the number of complete oscillations done by the oscillating body in 1 second. And this is measured in what? This is measured in hertz, a unit which is called what? A unit which is called hertz. This unit of frequency here, as we said, is hertz, may be in many units like kilohertz, which equals 1 times 10 power 3 hertz, or megahertz equal 1 times 10 power 6 hertz, or gigahertz, which equals 1 times 10 power 9 hertz. These are here the measuring units of frequency. So here the complete oscillation consists of what? Consists of 4 amplitudes, as you can see, 4 amplitudes. Okay, or we can see that one amplitude is considered as quarter of complete oscillation. Quarter of complete oscillation. Okay, this is about here the complete oscillation. How can we calculate the periodic time and frequency? Periodic time can be calculated by calculating the time in second divided by number of complete oscillations. And the opposite to it is frequency, can be calculated from the relation number of complete oscillations divided by time in second, as you can see. So the periodic time here can be calculated by dividing the time in second divided by number of complete oscillations done by the oscillating body. And this is measured in second. How can we calculate the frequency? We observe how many complete oscillations done by the pole of the simple pendulum and divide them by the time in second. In this way, we can get the frequency, and as we said, is measured in what? Is measured in hertz. Number of complete oscillations, as you can see here, divided by time in second. Okay, this is about here how can we calculate the frequency and the periodic time of the oscillating. So here we conclude that the relation between frequency and the periodic time is what? The relation between frequency and the periodic time is inverse relation. As we can calculate here frequency by dividing 1 over periodic time. And the opposite also, we can calculate the periodic time by dividing 1 over frequency. So if you are given the periodic time in the problem and you are required to calculate the frequency, you should here divide 1 over periodic time. And the opposite is right. When you are given the frequency in the problem and you are required to calculate the periodic time, you should here divide 1 divided by frequency. In this way, we conclude that the relation between frequency and the periodic time is inverse relation. So when you ask it here, the product of multiplying frequency by periodic time equal what? Equal 1. Equal 1. Why? Because the relation between frequency and periodic time is inverse relation. In this way, we reach the end of the lesson of oscillatory motion. I hope you understand it, and I hope you a good life. Thank you, my dear students, and goodbye.